Hi everyone, my name is Alex Ignatov. I'm Senior Data Scientist in AWS Professional Services.
And I'm Mridula Balasubramanian. I'm a Senior Solutions Architect with AWS Worldwide Public Sector Solutions Architecture.
Today we are going to talk about generative pre-trained transformers and how you can quickly start experimenting with GPT-2 model available in AWS Marketplace. Generative Pre-trained Transformer Concept, or GPT, was first published by OpenAI organization in June 2018 in a paper called Improving Language Understanding by Generative Pre-training. Previously, most of the approaches to generate text were based on the recurrent neural networks. RNNs, such as LSTM neural networks, are usually were restricted by short range of input sequences they could effectively perform on. In this paper, authors for the first time outlined approaches on how transformers can be used to utilize pre-trained in an unsupervised manner model and improving capturing of longer range linguistic structures for purposes of generating new text. In February 2019, second version GPT-2 came out. GPT-2 is a very large transformer-based language model trained on a massive dataset that features much larger number of parameters. This model became significantly improved successor of GPT. It received wide publicity for its capability to generate very plausible-looking essays. Recently, GPT-3 paper was published. GPT-3 has even larger number of parameters, but today we are going to focus on GPT-2 model. All these three models have some main concepts which allow them to generate highly coherent text based on provided input text sequence. First concept is masked self-attention. Self-attention is one of the key components of what is called transformers architecture. The core idea of attention is to focus on the most relevant parts of the input sequence for each output. Here you can see visualization of attention mechanism. The sentence, "Machine learning is great for humanity. It helps." Let's imagine that model is trying to predict the word helps based on the previous words. We are using attention visualization tool to see which parts of input sequence have more influence on what next token model will generate. You can see on that picture that word helps is contextually influenced by machine learning, which is at the beginning of the previous sentence. You can also notice there is an influence by word humanity. Attention mechanism allows model to look further in the input because often nearest word may not have enough context to predict what should be next. This picture is just a representation of attention in one layer and one head of a model. Other combinations of layers and heads can have much more or less obvious relations between position in a given sequence of tokens used to generate next word. In this picture, the darker blue color corresponds to higher attention scores. This is a good way to have a 10,000 feet view on how attention works. Positional encoding enables transformer model to keep track of absolute or relative positions and distances between sequence elements. GPT-2 is the model with absolute positional embeddings. This method allows model to attend on order of the words and distance between them. To show what it is, I have plotted mean values of positional embeddings for each position in a sequence. On the right, you can see large scale of 500 or 1,000 words, and the mean value of positional term follows a sine wave. On the left, we have the same values, but only for first 100 tokens. In fact, it has more complex structure. It's not strictly sine wave. Positional encoding values are essentially values that being summed up with word embeddings inside the model to adjust meaning of each word depending on their order and position in a sentence. Subword tokenization method is based on byte pair encoding method. Byte pair encoding is multi-pass data compression technique in which the most common pairs of consecutive bytes of data is replaced with byte that does not occur within that data. GPT-2 subword tokenization merges most frequent character pairs found in text corpus into n-gram tokens and records them into vocabulary. This process runs iteratively until either desired vocabulary size is reached or when there is no more merge operations can be done. Besides that, there are several specific to text generation parameters that you can adjust to produce better output text. First is the temperature. Temperature controls the randomness of predictions. Higher temperature increases the sensitivity to low probability word candidates. However, that decreases output text coherence. Therefore, text produced might be less meaningful. Values lower than 1 make output more conservative, but you might get the same result for a specific input text over and over. Top K sampling limits sampling pool of output tokens to K number of candidates with highest probability. For example, as you can see in the bar graph on the left, when you specify k equals 2, you are telling the model to choose the subsequent word for the sentence on the left from only top 2 suggestions. This sampling technique eliminates possibility of choosing non-suitable candidates for the next generated token, even if temperature parameter is set to high value. Top P sampling. Top P is a nucleus sampling, and unlike Top K, chooses from the whole distribution. Nucleus sampling optimizes for the minimum number of candidate tokens to sample with highest combined probability. For example, when top P equals 0.9, it looked for all the potential candidates with a cumulative probability of 0.9 and then choose the smallest set. In this case, you can see that with 3 words and, story, and law, it was able to form that nucleus to choose from with very high probability without limiting to a specific number of samples to choose from. Depending on a specific text and context, top P sampling may produce better results than top K sampling, and vice versa. Now I will pass it to Marut to talk about GPT-2 use cases, architecture, and demo.
GPT-2 has a number of use cases, but really the primary use case is to generate text. And it does this by taking an input prompt as context and predicting the next set of text. So in this toy example, I start with a really short prompt, couple words, NLP is, and GPT-2 provides me predictions with associated probabilities for the top 3 candidates. I pick the top prediction and I use that to continue my prompt. And the model then generates additional predictions based on this longer context. And so it continues. Now, this is a simple use case for auto-completion, but you can use large models like GPT-2 XL to provide more verbose text generation by using its longer context window of 1024 tokens to prime the model. So GPT-2 has been performing state-of-the-art on text generation, but it is also performed on other language tasks such as reading comprehension, natural question answering, summarization, and unsupervised language translation. Generative models are an active area of research because the insights that they provide from their behavior help researchers understand how unsupervised learning works. And research is underway to find generalized architectures where you can create an architecture which can perform across various language tasks by using no fine tuning, but instead by using in-context learning or meta-learning. Another area of interest is model bias, where researchers are looking into the neurons of the model to figure out if there is bias and methods to mitigate that using attention visualization techniques. And interpretation of predictions is an area that is of interest across various deep learning models. Now, GPT-2 has been trained predominantly on text data, but there is interest from various research organizations in incorporating images, audio, and other modalities of data so that the model can be adapted to tasks such as visual question answering, music generation, code completion, etc. So in the demo segment of this presentation, I will be using a GPT-2 extra large model that I subscribed from AWS Marketplace. And these are the steps that I took to deploy it onto Amazon SageMaker. So first, AWS Marketplace is a place where you can go try out and buy different algorithms or model packages that you can then deploy onto Amazon SageMaker. And these training and inference containers are in network isolation mode. And these containers, when they're deployed, have no internet access for advanced security. And as a user, you can configure your endpoint in your Amazon Virtual Private Cloud and create those identity and access management policies so that you can give granular permission to SageMaker to access resources inside your AWS account. And the inferences itself that you make can be either real-time or asynchronous batch transform method. And the API call itself is secured in transit on SSL. So in the demo, I use an Amazon SageMaker Jupyter Notebook to make inferences against SageMaker endpoint. And there's also code in there that you can try for doing batch transforms. So onto the demo. So here I am inside Amazon SageMaker Jupyter Notebook. And first off, let me show you how to go to AWS Marketplace to find the product of interest. So here, this is GPT-2 Excel for text generation inside of AWS Marketplace. You can look through the overview, the highlights, and the usage information that helps you understand how to use this model and maybe some sample code. And back to the Jupyter Notebook itself, I start off by installing various libraries, and one of them is WordPress Package, which is an open source self-attention visualization package. And we provide you a snippet of code where you can go explore and see how self-attention works inside GPT-2. So in this case, for example, if you focus on a word, it shows you the contextual relationship of that word to other tokens in sequence. And that helps you understand, gives you insights into how the model makes its decision in predicting the next set of words. on to the use cases. So one of the important parameter, of course, is your input prompt, where you provide the string to condition your model to prompt it for text generation. But in addition, there are a number of other parameters that you can tweak to influence that model behavior. One of them is length, for example. So in this case, the default is 50 words that it will generate in the output, but you can increase or decrease this value. And there are a number of other parameters that you can explore. So in this notebook, we look at a use case where you can use GPT-2 as a writing assistant. So let's say, for example, that you are a writer of prose and you haven't yet decided what to write about. So this first example here just gives you a starting token without any specific prompt. And then it lets you just go ahead and execute it. And you'll see some unconditional sample that gets generated by GPT-2. But let's say now that you've decided on a topic, you can provide that as a short prompt to the model to prime it. And then when you execute it, you will see that the model generates text which is related to your prompt. So that's one way of using GPT-2 to assist you in coming up with ideas for writing. And of course, you can tweak the different model parameters for length. And if you don't want too much repetition, you can have a higher repetition penalty value. You can also use GPT-2 to autonomously author. For example, in this case, I look at using the model to write a Shakespeare-inspired poem by giving it a prompt and just running it. And you will see in the output that it tries to mimic the style of the prompt that I provided. So this gives you an insight into kind of its chameleon like quality, where it's adapting its text generation based on the conditioning that's provided in the prompt. And you can, of course, tweak various parameters like temperature, which is sensitivity to low probability words. So a default value of 1 is a more conservative model. So it's highly sensitive, so it doesn't use as much of those low probability words. And so you can pick a sample pool of words that you want the model to use in its output by specifying the value of top K. So one of the things that you can do is for the same given prompt, change the values of these model parameters. So in this case, for example, same prompt, but a higher value of temperature, which means the model is now less conservative, and see the difference in creativity of the output from the model. So that was the primary use case with generating text for prose or poetry. Now let's do some additional experimentation with language tasks such as reading comprehension, where I provide a context and then a question with a structure such as Q to indicate that it's a question, and then see what the model comes up with. So in this case, it comes up with an answer with A. So this is where I'm basically experimenting with the structure or the frame of the prompt itself to see if the model will recognize that specific task. And I'm doing this in a zero shot setting, which means that I have not fine-tuned this model for any specific task, but instead I'm using the prompt at inference time to train the model. You can additionally explore what is called few shot setting, which means in addition to providing the prompt context, you can also provide some additional examples of Q&A so that you are letting the model know what type of task that you're trying to perform and give it some examples. And then when you run it, it tries to come up with an answer based on that context. So that was for reading comprehension. Question answering. So this is just natural question answering where you don't provide a context, but you just ask a question of the model. And then based on its training on 8 million pages of web text, which is now encoded in its 1.5 billion parameters, it comes up with answers to your questions. Summarization is another language task where you provide a much longer context, so maybe a whole article, because the input context window for GPT to Excel is 1024 tokens. So you can use that to provide these longer context and then have the model, prompt the model with dots to come up with a summary for that article. In this experiment, I look at unsupervised language translation, where I provide a French passage and prompt the model for English translation by providing this keyword, and the model comes up with a translation. So in this case, I'm not really looking for the accuracy of the translation as much as I'm looking for ways that I can make the model recognize the task by using different structure in the prompts. So a slight variation from the previous, again, start with a French passage, but this time I give it English equals as a prompt to see if it will come up with a translation. So I highly encourage you to continue to explore with the various prompts, various structure of prompts, and different settings for model parameters to see how you can use GPT-2 for your own use case. And once you're done, feel free to delete the SageMaker endpoint so you don't get charged for it. And everything that I did with the inference endpoint, you can do in an asynchronous fashion with the SageMaker batch transform as well. And this notebook is available to you on GitHub, and I will show that to you in just a second. And there are, in addition to this GPT-2 model, you can explore other models in AWS Marketplace, and some of them are listed here, and see if these will serve your use case. So let's go to the GitHub repo, where you can find Amazon SageMaker examples. And under AWS Marketplace, you will see model packages, and creative writing with GPT-2 is the notebook that I just demonstrated to you. Please feel free to explore further for your own use cases. Some additional resources for you. Please go to AWS Marketplace, where you can check out different algorithms, different model packages, and then you can see YouTube videos on how to use them, read blogs, and of course, you can try products and use sample notebooks to help you try those products. And if you have any questions, you can reach out to the AWS Marketplace team at the alias shown. Thank you.